Hello, my lovely humans. So today we are going to look at 2024 paper, higher level project scheduling, critical path, early, late times, whatever. Those of you doing technology should have a better grasp of this than I do, probably. But we'll get stuck in. It's not too difficult. It's annoying. Um, I think anyway. So we just have to be careful. So as usual, we'll go through the question. I'll just explain it as I go. It will take a good bit longer than you will take in the exam. I'll answer the questions and then we'll look at the marking scheme and see where the marks are got. I'll just mark them on the question as we look back. So in this question we have a diagram. It doesn't matter what, making a car, whatever, the story's nice, who cares. So we got source node and sync node. So we start at the source and we do all those tasks and get to the sync node, which is the project complete. And the times there are the time, or the numbers there are the times taken for each task, or the weight, or the cost, or the weight, or whatever it is. And then the letters are the names, and it is very easy to talk about the points rather than the letters, so I probably will make a mistake and call it going to A or going to G or whatever, but the tasks, the letters are the lines with the arrows, not the dots. So forgive me if and when I get that wrong. So we want to calculate the early and late time for each event. Complete the diagram by writing the early time and the late time at the node representing each event. So even then that node it's a strange one. We have to have finished A by, so hopefully I'll use the correct language. Anyway, so we have the early time here is 0. So that's the early time for the start, because that's when the clock starts. So then we look from 0, what of A, B, and C only depend on the source node, and actually they all do. So A can start, A will be done by 3, B will be done by 5, and C will be done by 2. And now those are the easy ones, because A, B, and C depend on one thing only, so that's easy. However, we have immediately, when we go into this one here, this D here, D depends on A, the 3, but it also depends on B, the 5. So even though there's a dashed line, that's not a task that has to be completed. It's just a way to link to something that D is required, or sorry, B is required for D to finish. So it's not a task specifically, but it is a requirement. So that's what the dashed line means. It has a name and it has escaped me momentarily. So D, so the way I kind of work through this is I write the numbers, what numbers we have options for, what are the possible times, and then we see what the earliest possible time is. So if we go from A to D, so if we go from A to D, that's 3 plus 1, so that's 4 is one option. And then if we go from B with that dashed line, 5 is one option, is the other option. So what we have here is 5 is the answer, because we can't kind of start G until D is done and B is done, and the earliest that can happen is 5. So it's a strange, when we're doing the early times, we're kind of looking for the latest early time. Now let's have a look at, I suppose we'll look at the middle one now just to see what's going on with this. It's nice to kind of go from left to right, just because stuff as we get later depends on more things. So we'll look at this one now. So, well, what we know is 5 plus 7 is 12. So 12 is there. Then 2 plus dash is 2. And 5 and the dash is 5. So what's the earliest time where those three things will be complete? And it is 12. And now that 12 has a knock-on effect, and this is why we got lucky this time that the middle one had to be done before the bottom one here, because that arrow here is pointing down. So that's 12 there, and 2 and 4, 6. So what's the earliest time where everything can be done? And that's 12. Now there's so many arrows all over the place here. So let's just go up to here and have a look at this one. So what do we know? We know that 5 plus 3 is 8. So that's one. So if it's ADG, it's 8. Then we have 12 plus 4 is 16. And now we have a problem here that L has to happen before we can know exactly before we can go on to M. So we don't know what time L starts at, so we actually can't do anything for the moment. So let's have a look at the middle one now. I hope I'm explaining the process here. Please do let me know if I'm not, and I will endeavor to explain things better or re-record the video. So 12 and 5. So if we're going this way, we've got 12 plus 5 is 17 is one option. Oh, we've got these other arrows going in as well. No, I'm just going to, just so you're not confused, just because the colors, colors are important, I think. So we've looked at 2 times, and 8 and 16 were 2 options there. So we can't do anything with this because, again, we have the arrow pointing up there. So we got to go all the way down to the bottom, figure out this bottom right box here, which will then let us get the middle box, and then let us get that box. It's not necessary to have that vision for what's going to happen, but if you spot it, it's useful. So 12 and 6. So from 12 now, 12 plus 6 is 18 here from the bottom. From J, sorry, and then we have 12 plus 3 is 15. That's the K is the only thing going into that box. So 15 is the early time for that activity K to finish. Which means 15 is an option to go up to that middle box before L. So that is 18 is the latest of those early times. It's the time by which everything will definitely be done, or the earliest time by which everything is definitely done, which means that 18 is here. Oh, no, not 18, 19, because it's 18 plus 1. So it's 19, which means that 19 is the earliest time by which everything is done. And then we go 19 plus 2 is 21, and then 15 plus 4 is 19. So the earliest time by which everything is going to be done is 21. So what that means, it takes 21 time units, whatever it is, to get that completed. So those are the early times. Now we work backwards from the source, from the sync node, and find the late times. And what the late times are is the latest time something can happen so it doesn't slow down the project. It's not just any late time, because you could delay things as much as you wish, but it is the latest time that keeps the project on schedule. This is a way of showing us the flexibility we have built into our system to allow us to redeploy staff or resources or machines or whatever. So it's a really useful thing to be able to do. So the late time for the sync node is 21. So now we look at the various things, and we have to work backwards. I'll just do these in green now on the other side of the boxes. So we definitely know that 21 minus 4 is 17. There's nothing else coming out of that box with the 15 in it. So 17 is the late time for that to start. Wait a minute, there is something else and I didn't even spot it. So I forgot that this thing here was there. So that's a dashed arrow, so it doesn't take any time, but so this thing has to have been completed before we can get to here. So with this is this 18, so that thing at L, sorry, this means that another possible late time is 18. But if we started at 18, this thing won't have finished, because 18 and 4 is 22. So N won't have finished rather than this thing. So we want to find the earliest late time, and the earliest late time is 17 there. Actually, it didn't change my answer initially, but it was good to look at, because that box there is going to two places, and what's the latest each one could finish, or each one could go, was 18 and one is 17. But you want to make sure both of them are complete, so it has to be 17. So then what do we need to look at? What is, well, we can't deal with the top one here. Sorry, no, we can't deal with the top. We can't deal with the middle one, because the middle one depends on this one, on the top one there. So let's look at the top one. The only thing leaving the top one is the M. So, and that's 2. So 17, not 19. I was taking the 2 away from the wrong number. 19 is the late time for that. And now we can look at L, because what L depends on is that, so the latest L can start is 19 minus 1, which is 18. That's the only thing that L is going to, or things are, well, the only thing that's leaving that box. See the trouble I have with phrasing these things correctly, because we're so used to talking about nodes and edges, and at the moment I feel the activities are the edges, but they're normally the nodes, or the box that we're filling in are the nodes. So it is confusing to speak about, so I hope it's okay. So now what can we look at? So I suppose now we look at the top and see this thing here. So what's happening here? We know 19 minus 3 is 16. So that's one possibility, but as before, we have this arrow leaving here. So we have to deal with the middle box before we can deal with the top. So we have to deal with the 12 before we can deal with the 5. So let's look at the 12. So there's 19 minus 4 is 15 is one option. 18 minus 5 is another option, so that's 13. But we have this arrow here, so we actually have to deal with the bottom one first. Yeah, and the numbers I put there are not waste of time, because they are the relevant numbers. We will very quickly get the answers to the rest of the top. So it's useful not to worry about the consequences until you've just get the base of what we know in, and then see what else we need to find out. So then we have 18, so going in this way, 18 minus j is 12, and then 17 minus 3 is 14. So 12 is the late time for that one, which means that has to be 12 there. So what's the earliest late time? So this has to be 12. because we have to be gone by 12, and so that means the 15 and 13 will have to be done by then. And then we go back up, so that's 12, and that's 12 again. So 12 is there. Now that activity at A here, the first one has a huge amount of flexibility. I think that's just 11. 12 minus 1, yeah. So it's the only thing that's leaving that. So that can, the latest we can be done with A is 11, which is like a time between 3 and 11. So there's a huge flexibility there if that was what the question's asking us. It is often the critical path, but it could just as easily be about what tasks have the most and why the most flexibility, and why would that be relevant. So then we go to B is 12, and 12 minus 7 is 5. So that's 5. And then we have 12, that dash thing, and then 12 minus 4 is 8. So that's 8. And then all of these have to come back to 0, because you have to start at the same time, so the early and late time. And actually we can work it out anyway. So 11 minus 3 is 8, 5 minus 5 is 0, and 8 minus 2 is 6. So that 0 we get there is necessary to have done it right. If you don't get a 0 as your late time on the source node, you've done something wrong somewhere. So I would say if you get a non-zero source node, I would just move on and don't stress, because I think trying to find a mistake might be too difficult in the heat of battle when you've got other stuff to do, and it might not be worth it for the marks that you're going to lose. Maybe don't answer the rest of the questions till you get to the end of the exam, or till you've finished everything you can, then come back and try and find your mistake. And then once you've found it, you can answer the next couple extra questions that there are. So that is the process then, is you go from source to sink to find the early times, and it's the latest early time, and then you go from sink to source to find the earliest late time. It's how I like to think of it, but hopefully that makes sense. I'm happy to go in slower and in more detail if you guys need that for the next little while. But now we're going to look at just the supporting questions. Write down the critical path. So the critical path is the path where the source and sink node, and it says, does it say paths? It says paths. Okay, so where the source and sink, or sorry, not source, the early and late times are the same. So we got that, but we also have that. So there's a couple of contenders. There's a lot of options, and this as well. This thing could go here. So how do we figure out which of these critical paths are correct? Are they all correct? Is there a distinction we can make between any of them? Where we go now? Just go up one more time. Go there. No, not there. So there. So there's options, and it's starting to look messy. So with the critical path, we have to think of it. Early and late times have to be the same, but is there something else? And there is something else. What we have to see is, what are the activities that cause the critical path? So in this case, and hopefully this will make a bit of sense when I go through it. So here's our 2121, and we want to get to 0, 0. So which of these activities has absolutely no flexibility? So the N has some flexibility, but the M doesn't. because 21 minus 2 is 19. Okay. Now, which one of these activities has absolutely no flexibility? This h is 4, so 19 minus 4 is 15. So even though this source node is 12, it has the same early and late times, that h is not on the critical path because that does have some flexibility in theory. It is not the thing causing the path to be these exact numbers. So, but 19 minus 1 is, so that's definitely, that has no flexibility because 19 minus 1 is 18. Now what? So 18 minus 5 is not on the critical path because 18 minus 5 is 13. But 18 minus 6 is 12. So there's no flexibility. It's that J task causing the critical path to have these values. Then we go up to here, because that's 12. Then it's 12 minus 7 is 5. And then 5 minus 5 is 0. Cool. So the critical path then is, it's not just the boxes where the paths that connect the boxes that have the same early and late time. It's the tasks that cause the critical path to be what it is, or that cause the times to be what they are. So the H and I are connecting boxes on the critical path, but they have flexibility built in. They're not the things causing the times to be those exact times. So the critical path is B, E, J, L, M. Then what is a critical path? A critical path is the thing that the set of activities that cause the project, that if a delay happens in the project, it will cause, if a delay happens in that task, it will delay the project as a whole. And then if K takes 5 instead of 3, what effect will this have? If K takes 5, which one's K? If K takes 5 instead of 3, what would that do? And this is where it gets messy on the diagram. If K takes 5 instead of 3, will that do anything? So I'll just do this in orange up here. So if K takes 5, instead of 3, 12 plus 5 is 17. So that would change the early time to 17, wouldn't it? But it wouldn't change anything else. Because 17, I suppose it would possibly put, what effect will this have on the critical paths and the time it takes? I don't think it will change anything about the time it takes, but it will add a second critical path where you'd have Kn. Because see, this thing, if that now is 17 instead of the 15, it doesn't affect that, which means that the 21 is still correct. And then 17 plus 4 is 21, so that's still correct that way. So it won't change the time it takes to complete the project, but it does add another critical path, which I will just look at in green, if it will let me. So if this is 17 then, so it's 21 minus 4 is 17. So that is critical path. 17 minus 5 is 12. And this then joins up with the critical path we have already. So it would actually create two critical paths. You have the one we have before, that one there, so B, E, J, L, M. And we'd have this one here, which would be BEKN. So there would be two critical paths, but the time to complete the project has not changed. Hopefully that makes sense. What we're going to look at now is the marking scheme, just to see what the marks were for this and how they were divided up. It is question 8. Question 10. And question 10. So completing the graph was 20 marks, and it was 0, 8, 14, 17. So I would imagine it's something like 8 marks for either the early or late times correct, 14 marks for one correct and mostly correct for the other, 17 for everything correct or everything but one thing correct, and 20 overall. So I'd say it would be 8 for, say, the early time, 14 for the late time, or the other way around. Or then 17 and 17 for one correct and another one almost correct. Calculate the. I'm not really sure how we can have 5 separate sections there when you've got 2 things. I suppose there's a possibility that the dotted lines could cause some error. So maybe 17 is for correct with 1 mistake or 2 mistakes to do with the dotted lines. Then writing down the critical path was worth 5 marks. Then the critical path where a delay in completing an activity will delay the overall project, so that's 5. And that's why the critical path was the one it was, because there was no flexibility in the timings of those tasks. And then part 4 was there is no effect on the time, but there's a new critical path, which was 5, which is exactly what it said. So what's that? That's 20, so 20 in total. So that was 35 marks. I think 20 for the graph for the early late times is brilliant, because it's no matter how difficult it is, it's the same process. And there's, you can be fairly happy you've got it right if you get 0 as your source node at the end for your late time. I'm not sure if I have explained that as well as I could, so please let me know if there's anything that you're not clear on. And yeah, good luck.